In this class, we're going to consider algebraic formulae. And a formula is really just a way of expressing a rule mathematically. And a rule is just a set of instructions, it's an operation that you want to carry out. So it used to be that we wrote these down in words. If you wanted to express your rule, your operation, we wrote that down literally in words. That was before we had symbolic algebra and the idea of a variable. So if you wanted to take a number and have a rule that said to multiply that number by 4, then literally you had to write down, if you wanted to capture that, something like, take your number and multiply by 4. So, I mean, literally had the words multiply by 4 in it. But then we developed symbolic algebra and we realized, hey, we could say, right, let's represent any number by the variable x, and if you want to multiply that x by 4, then that can just be captured in the algebraic formula for x, like this. So that would be a very basic example of a formula. That algebraic formula expresses the idea of taking some variable and multiplying it by 4. Okay, so that is the rule. The rule there is take any number you can pluck out of your brain and multiply it by 4. That is what that is telling you to do. And as you get further into more complex rules, then you just need more algebraic terms to express them. So say, for example, you wanted to carry out the operation of taking some number and, I don't know, like dividing by 3 and then doing something else. So then, say, subtract 5 or something like that. So again, back in the olden days, we would write that down, literally, divide by 3, then subtract 5. But now we can use symbolic algebra and variables to represent that. So we just take our variable, that's the imagined number, which we're going to use x for, and we're going to say, well, take that x and divide by 3, okay? I can represent that, x over 3, then subtract 5, so then subtract 5, like this. One of the things you'll quickly start to realize about rules, about formulas, is that if they've got multiple terms, multiple operations, then the order of those operations is really important. So in this example here, your variable x has to be divided by 3 first before we take away 5. So we're not going to look at that in detail in this class, but just be aware already when you're using algebraic formula to represent rules that the order of the operations have to be correctly captured in the formula. A no-brainer here, because there's only this one term. This one here, though, a lot of students initially, which is quite understandable, will think in their heads x minus 5 divided by 3 instead of x over 3 minus 5. Seems like quite a trivial thing, but it's super important getting the order correct. A lot of mistakes are made by not interpreting the order correctly. So the idea of an algebraic formula, sometimes it can just be a made-up, purely mathematical object. So I could just make up a formula. I could say that I want my letter z, or z, depending on which part of the world you're in, to be equal to something like, let's say, 5x minus 4, and I want to divide all of that by 2. So I've just made that formula up. It doesn't mean anything, but I could start to substitute values here into the variable x, and every time I substitute in a different value, I'll get a different value for z. Okay, so that's just an example of a made-up algebraic formula. But of course, in the real world, there are many actual algebraic formulas. So the formula, which I think I used actually as an example in the previous class as well, quite a good one actually just to introduce, is to convert temperatures. So if you've got a Fahrenheit temperature and you want to convert it, then we can plug that variable, that f value, in here, and then you can convert it to the C value. Okay, so that would be an example of a formula which is actually used, not just a made-up one, actually used in the real world. So that's the idea of an algebraic formula. Generally, when you're starting out with algebraic formulas, you just want to understand why they exist. Well, they exist to represent a rule. You want to understand how they're made up. They're made up of algebraic expressions, and in particular variables, and we looked at variables in the previous class. You've got to have variables within a formula or else it's not going to be a formula. And then later on, you're going to kind of, and this is beyond what you need to know now, but you're going to take these and formalize them by calling them functions, and you're going to study the properties of those functions, and that's called calculus. So you've probably heard of calculus already. So calculus is really built up to by learning these ideas now and then taking them forward in the future. So that's the idea of an algebraic formula. In the next class, we're going to consider using algebraic formula, which is just the starting point really if you're new to this. And when you come to use them, you just really substitute in values and you get the output value. So with a formula, we would usually call the variable, the thing that you're putting the numbers into, we would call that the input. What you get out when you perform the calculation is the output. And that idea of output and input is really important when you're working with algebraic formulas. So we'll take this a little bit further in the next class.